Hello, my name is Taylor Ann Smith, and my pronouns are she, her. I'm a master's student at California State University, Northridge, studying the patterns of microplastic pollution in deep sea habitats. Microplastics are defined as any small plastic piece 5 millimeters or less in size and have been discovered to be ubiquitous throughout marine environments. And as inorganic material that can never fully break down, it will only accumulate over time. That is, if we don't take action. Microplastics have been ingested across all trophic levels and organismal size classes, such as zooplankton, and if ingested, can block the gastrointestinal tracts of organisms and expose them to toxic chemicals that can adhere to the surface of plastic. Due to the harmful effects plastic pollutants have on marine life, it's important to understand where they may accumulate over time. National marine sanctuaries are marine protected areas that are protected from certain harmful human activities. However, this does not include the protection from all threats of pollution. These sanctuaries protect invaluable oceanic biodiversity and are home to unique deep sea habitats consisting of rare species. Thus, it's important to monitor any potential threats such as microplastic pollution. So that leads me to my research questions. I wanted to know, how do the abundance and types of microplastics vary across the Monterey Bay and Channel Islands National Marine Sanctuaries? And do the types and concentrations of microplastics change as a function of proximity to shore and as a function of depth? So to answer these questions, water samples were collected via the EV Nautilus opportunistically in conjunction with other scientific operations. Therefore, sample volumes and locations of samples were not always the same, and not all organisms were resampled at each site. From multiple sites within the Monterey Bay and Channel Islands National Marine Sanctuaries, there were multiple samples collected, in addition to some unprotected areas that are proposed to be a future sanctuary or in addition to a sanctuary. So here you can see 10 sites that I collected some, like I said, each consisting of multiple sample collections, and they were collected via Niskin bottles on ROV Hercules from depths ranging from 3,500 meters below the surface to my shallowest sample at around 47 meters. Once these samples were collected from each site, they were filtered for microplastics using a 1.2 micron polycarbonate filter. Blanks consisting of DI water were also processed using the same materials and techniques as the samples. Once each filter was processed and stored in its own Petri dish, I counted the number of microplastic seams once returned to the shore. The volumes of water filtered for each sample was dependent upon the volume retrieved from the ROV, but the number of microplastics seen were standardized by the volume. There was a total number of 3,014 microplastics, and there were microplastics in every single collection that I made, inside and outside of the marine protected areas, within shallow waters, and within the deep sea. To answer my first research question, this figure shows that the total number of microplastics counted per liter of water on the y-axis, with the collection of sites listed in order from the farthest from shore on the bottom x-axis, and the black bar represents the mean. The sites from the South Incapa slope all the way to Pioneer Canyon are within 50 kilometers of the mainland shoreline, whereas the remainder of the sites range from about 85 to 122 kilometers from the mainland shoreline. And here you can see the scatter plot that shows the number of microplastics per liter as a function of depth and distance to shore across all sites and samples that I collected. On the y-axis is the distance to shore in kilometers, and on the x-axis is the depth the samples were collected at. Unlike I hypothesized, we see a slight increase of microplastics as depth increases, which is not actually what I first expected to see. Deep sea habitats, we are just beginning to understand them, but yet they are already threatened by microplastic pollution. We tend to think of these habitats as so far removed from the influences of humans because they're not close to shore and they're in really deep waters. However, what we are seeing with my sample collections is that the water around these rare deep sea habitats potentially may just have as many microplastics as shallower waters closer to shore. Now that we know that microplastics are in fact found throughout the water column in shallow waters and within the deep sea, the next step is to see if they are also within the deep sea organisms. Next, I'll be processing deep sea organisms, including urchins, sea pens, and sea pigs, to determine the number of microplastics ingested in comparison to their surroundings. Drift kelp was also collected to determine if it may act as a vector of microplastics into the deep sea. With that, I would like to thank all of my collaborators, mentors, and friends and family for their support and guidance on this project. Thank you.